All right, if you are not prepared to pay very close attention, you are wasting your time. This is one of the more challenging problems in the book, I would say. So that being said, let's get into it. Okay, so we have been given a diagram, and if your parents want to watch this, this could actually be a project you could use. And at the very end, I'll give them a little pointer on how to actually make it work if you wanted to make it yourself. So we're going to put a fire pit standing or in the ground or, one of those tall ones outside. And it's going to be square. So that's important. So it can't be any other size. And then around it, we're going to use 1 foot square stones. Okay, these could be any stones that we like. And then as we get away from this, right, we're going to keep getting bigger and bigger as we build out some sort of a, if this was on your patio, it could be an actual patio, or it could just be a nice little frame for it to make it look nice. It could be far enough away from it where you could set chairs and it would look nice, and then have concrete on the outside. I'm talking to parents at this point. There's lots of options. But anyway, so let's see. So the first question they ask is, how many stones does it take to border the fire pit with 2 rows of stones? Okay, so that's what they've shown us, these 2 rows. And before we do that, they give us this helpful choose the diagram. So they want us to choose the diagram that best describes this, and there's a choice of 4. And as you can see, this is the side length S. This is a side length S, right? As you can see, it goes all the way up to the side length of the fire pit. And then the first row is going to create 4 of these. You're going to also need 4 blocks. So if S is 5 feet, then that's going to be 5 here, 5 here, 5 here, 5 here, plus the 4 on the outside. So that's kind of an example. In the next one, each side is going to have this S plus 2, this S plus 2, this S plus 2, and this S plus 2 with 4 extras to go into the corners. Okay, so with that in mind, the way it works is the first row is just, let's go ahead and color them as we, so if we just count the S's, the first row is just 1, 2, 3, 4 S's plus 1, 2, 3, 4. So the first row in blue would be 4S plus 4. Okay, now in the second one, instead of just having S's, we have S plus 2's. And we have 1, 2, 3, 4 S plus 2's. Okay, so the way we would write that is, well, we're moving to a new thing. So plus, and then in red, we're going to have 4 times S plus 2 plus the 1, 2, 3, 4. Okay, so row 1, 4S plus 4. Row 2, if we distribute, is 4S plus 4 plus 4. Therefore, we have, well, let's bring it all down here, plus 4S plus 4. Nothing needs there. So we have 4S, 8S. So 8. Oh, I just realized a mistake I made. 4 times 2 is not 4, ladies and gentlemen. It is 8. That's a common mistake when distributing, is to distribute the first one and then get ahead of yourself. So always be kind of checking yourself. Good. I'm actually glad that happened. Okay, so all together, well, we're not adding blue here, so that's going to get confusing. Let me make my eraser smaller. Bear with me, guys. All right, we're gonna get through this. This is a great problem. Fantastic. Absolutely love this problem. So we end up with 8S because I added this and this. And then we have 4 plus 4, which is 8, plus 8, which is 16. So the answer to how many stones does it take to border the fire pit with both rows is 8 plus 16. 8s. Can't copy my own writing. Is 8s plus 16. Okay, so keep in mind though that is with the row 1 being blue and row 2 being in red. So row 2 was this 4s plus 12, or actually 4s. I would think of it as this part right here is what you're going to need to think of when we do the nth row, okay? So that moves us to our last one, the nth row. So it's not saying, and this is where I think I got a little bit backwards when I was trying to explain this to the first kid, and the reason I'm making this video is because it's not saying the n. It does actually say the fire pit with n rows of stones, but the answer they actually want to know is how much would go in the nth row, right? So the third row would be a new amount, the fourth row would be a new amount, right? So we want to know how many stones are in just the nth row. Okay, so the way that would work is we kind of have to think, like I said, that 2. We have to think about this. So what changed? Well, here's the 4 and here's the 4. But instead of this being s, in the second row, it was s plus 2. Now in the third row, and trust me, I've drawn this out, so I'll just draw the top. In the third row, if you can imagine, the third row would look like, well, it would look like this. And the third row would come out further, right? Okay, and create a new, here's our 4 that goes around. And then we would have this line, and we would have this line. So we added this and this to our s plus 2. So it's actually s plus 4. So notice that this is where it gets a little confusing, so focus. So this one was 4 times s, correct? This one was 4 times s plus 2. But row 3 is not 4 times s plus 3. Okay? It's actually 4 times s plus 4. And that is a very common thing when we do these nth row problems. Typically speaking, if something says what is the nth blank of this, you're gonna need to figure out a way to put n minus 1 in your problem. That's just how the nth row works. And to be honest with you, I used to have a good explanation for that, but let's just move on. We're in 7th grade here. All right, so the place that the n minus 1 goes is right here. So watch this. So if we know we have 4 sides of a square. So we're going to have 4 times s, but instead of it being plus 2, it's going to be plus 2 times this n minus 1. Okay, and then if we want, we can make this brackets. This is why we learn new kinds of brackets, okay? And then plus 4, right? Because it's always going to have this last outside, right? This outside corner where we had it here, and now we're going to have it there. Plus 4. So, order of operations here, or let's test this. So let's see if that makes sense for our third row. That's how you test your theory. Check out the third row. This is time consuming, but it's worth it. 2 times n, or wait, what I mean is n minus 1. So in the third row, 3 minus 1 is 2. 2 times 2 is 4. And that's what we expected here, right? We expected it to be 4. In the fourth row, it'll be 4 minus 1, which is 3. So there's actually going to be 6, which makes sense because there'll be 2 more. There'll be 2 more added on to the end of that one. So this is our formula. We just have to simplify it, so the kids should know this one. So order of operations says to simplify this first, so we end up with 4 times s plus 2n minus 2, remembered that time, to multiply all the way through, plus 4. And then we're going to distribute this 4. So we were learning some this was a crazy problem, kids. But so if you're even following me, you're ahead of the most, I would say here. But I don't like to leave things unsaid, because I think stretching our brain is important. And this is a real world problem that would be useful. So we have 4s plus 8n. That doesn't change. 4s plus 8n, I can't combine those. I can combine this negative 8 and negative 4, so it'd be minus 4. Okay. So, parents, kids, you can tune out. Parents, if you wanted to actually make this out back, you could create a spreadsheet, and you would have to have a cell for S, right? So if you do spreadsheets, you have to create an S would be the side length. So if your fire pit's 5 by 5, then S would be 5. If it was, you want to make a huge one, 8 feet, S would be 8. And then how many rows do you want to stack? How many rows do you want to stack beyond the fire pit would be your N. So let's say I wanted to do 10 rows and make a 10 by 10 patio with a 5 by 5 a 5 by 5 fire pit or whatever in the center, table, whatever you want, right? So then I would put N is equal to 10. Now just remember that you would actually be doing, you would need it to add the rows together though. So this, and I believe there's a way to do that, but you could also manually do it. So row 1, so in row 1 you would just have a static 4s plus 4. And then that would be added to this, where'd it go? To this formula. So you'd put the E, if you haven't done Excel, actually if you haven't done Excel, you're probably already checked out here. But if you put this in, so this S would be, whatever cell you chose for S, and this N would be whatever cell you chose. So this might say 4 times A1 and 8 times, A2, B1, whichever one you choose, right? And then that would just need to be added to your 4s plus 4. So row 1 is 4s plus 4. Row 2 is this with the 2 here. Row 3, and then it would need to be plus row 3. And there is a way to do that. I can't remember. It's been a while since I've done Excel, like a serious Excel. But anyway, you could definitely play with it and figure it out. But like I said, so this would be, if this was row 2, it would be times this. But then if you drag down the formula, like if this is the thing, if you drag this little corner box down, it will change this. If it sees that you're changing your N each time, it will change the N in sequence. So then you could basically drag that down and it would keep showing you the sum, it would keep showing you this formula performed, and then you just take the sum of all of those values. Anyway, call me if you're actually serious about trying this. It makes sense to me. I think I kind of messed up that explanation, but anyway, all right. Hope you guys are safe and well. Have a good Thanksgiving, and gotta love this problem.